So I will teach you the net and XNet, VGG, something like that. Okay, the backbone. So I'll start to teach it from here up to here. The backbone. So this for your reference. I already put a lecture on the FTP site. You can download. So just briefly tell you, okay, the undergraduate, we teach linear algebra. Okay, you learn the probability. And then you learn signal processing, because the linear algebra we teach you that it's a linear combination. 线性的好，线性 linear combination. So linear combination combined by sine cosine. And in wavelets, in image processing, we have a continuum. So it's wavelets. And after wavelets, and we also teach you the in the other OpenCV class, I teach more about here. But in this class, I won't teach you image processing. But in this class, I teach you more about computer vision, machine learning. But for undergraduate class, I teach more here. But this class, I teach you more about here. Okay. And the deep learning. So finally, it's deep learning. Okay. So we'll continue. So for the deep learning, we already know based on two steps. One is the feature extraction. The other, after you have a features or feature descriptor, right? And we do the classification. So two steps. Okay. But sometimes if you need an original image size, and we do encoder and then more decoder and then more like a result. Okay. So here, you should understand this one. This is a W is weight. The parameters we want to learn. And what's F? F is the activation function. So Z is what's input. So you have an input, and you have a weight. So input is known. You know input. You collect data to input, and you doesn't know F. Doesn't know W. And after you have input, you have parameters. And what's F? F is your model, like a Gaussian model. If it is Gaussian model, you write n normal distribution. This function is an activation function. Activation is nonlinear transform. So if from one domain, you transfer to the other domain. So it's F. And finally, your output is Y. And Y is your output. You compare with your ground truth. So this is a simple model or simple equation, this one. Okay. And in here, actually, you think about, I have a model. This is called modeling. I have a modeling, and I will try to estimate W, right? I know W. So what kind of a function I try to solve? So is this function. So this function, so this is the estimation result here. And what's D? D is your ground truth. So we just mentioned D actually is B, and this AX equal to B prime. So this estimation result, this ground truth, and you want to minimize this term and reduce the error. So you want to minimize this one. We hope that the error term becomes 0 or close to the 0. So the attenuation. However, in our reality, we have a noise. So this one is in theory is this one, but in reality, we call regularization term, one more term, because in reality we have a noise. Okay, so in the machine learning, the attenuation, we have a regular equation term also have a noise term. So this is more robust. So we try to solve is try to minimize all of them. Okay. 我实际上觉得这是他 paper 写的啦，那我觉得他 this paper is something wrong. Usually we minimize here. Minimize is outside here, not inside here. Okay. So be careful. We have one more term. This noise term. There's in reality. Okay. 好，那这个大概这个刚刚有提到的 ，this is a ground truth, right? This estimation result, and this output is y or b. So this is a b prime or y prime, and this ground truth. Okay, and we try to minimize entire one. So this is a function. D is a function. Okay, and function usually for the attenuation function only have 3 types of function. Only 3 types of function. We call norm, N-O-R-M. Norm is distance. The error, distance meaning what? The error between 2 points. Okay, so I have a norm. One is the half. The L half is let's call Euclidean distance. Euclidean distance. One is a SAD, sum absolute difference. The third one is a sum of square difference. So for the long term, for the distant measure, only 3. We call norm half is Euclidean, 就那个有拉距离 Euclidean distance. The second is a SAD, sum absolute difference. The third is a sum square difference. So you'll find your error term here. Okay, 3. But in deep learning, nobody use Euclidean distance. Why? Even though machine learning, people don't use Euclidean distance. Why? Because they are square term. The square term, square root. That's complicated. So don't use that one. Okay. So remember, it's a SAD and SSD. But most of when we teach you, right, we say deep learning either is closed form solution, right, or SSD, or they change to mean square error. But right now, people use L1, right? Sum of square difference is L2. They call L2 solution. L1 solution SAD, so they call L1 smooth. So deep learning has L1 smooth. They use sum absolute difference. Okay. So deep learning uses both L function. So our purpose is try to find minimum value here. Okay. The error term is your weight. So this look like a gradient descent one. Okay. And we already finished this one, so we continue. 这个我前面都教了，我就跳过去了啦，哈。啊，这自己注意一下哈。This I just give you for your reference. I say deep learning uses stochastic gradient descent, but actually stochastic gradient descent has some problems. Okay, because they need to have a many tuning. It's meaning that need have a learning rate. They need momentum. So they have some like Adam, use Adam. They have some parameters you need to give it, you need to try. So that's not so good. Okay, so that's such this one. Okay, the second one is because you use SGD, so it's not easy to parallel process it. Okay, they told this way. And the pitch gradient, I don't know what's this one. Okay. But what as I know is that if you use SGD, the other one is the initial position, because for gradient descent, initial position is very important. Okay, but it's not easy to define the initial position. But they actually claim it's fine. It's not so big deal. Okay, so just that you know, just for your reference, don't worry too much. 这我就跳过去了，这之前我们都讲过了啊，就当你参考。 this one we try to tell you is this here is a small patch, because when you do the convolution, right, it's not easy to put entire image inside. It's too big. So we use a small patch. So there's a convolution field. So this one. So we call local receptive field for small region. So you need to scan 9. And here we try to teach you is so for different field, sometimes they attract the boundary. Sometimes they attract the, see here, this corner attract the corner here. Sometimes they attract the middle here. So then for the local receptive field, they do the extraction based on the filter. The filter coefficients they learn by themselves in order to extract different kind of features. So that's the advantage for deep learning, okay? Because they have many of filters. And here we try to teach you is that this the position difference, right? The position difference. So that's tell you the filter need to do the scan 9, because your position appear position in different position. So you need to do the scan 9 to do the search. Okay. The third is here try to tell you is that this orange one with the three parts. Okay, A, B, C. Right now here is why we need to do the downsampling, because your filter size is the same. So in the high dimension, your filter size can extract the local information. In the lower dimension, okay, the same filter size, you can extract entire head or entire object. So that's why we need to do the subsampling, which is downsampling. Okay, so to extract global information, local information. Okay, so based on those three concepts, local field, sharing weight. What's the sharing weight? Is this one? Sharing weight. This one, sharing weight. It's meaning the same filter but different position. Okay, the same filter but different position. Sharing weight. So based on the three information, okay, the design, and then we will start to do design this one. So I will use this the most simple case to explain to you again for the application. But the same, in this example, I will explain to you this before, this year 1998. And right now we have a new method, but new method can apply to here the same thing. Okay, we use a new method to apply to here, include a batch normalization. Okay, so that's it for today. So next week I will explain to you how to do the presentation of PPT file for your final project. Next week I'll teach you to do the presentation PPT file. Okay. Okay, so that's it for today. Thank you. 谢谢。